Okay, it's going. All right, while I'm collecting that, we're gonna do your notes, and I'm gonna give you these two problems. I'm not telling you how to do them, I just wanna see what you remember. Okay, that's actually what we're gonna cover today, and we'll go over how, but for now, you're kinda on your own. I'm gonna run through attendance just for my sake. I know everybody's here, but I'm just gonna say your name out loud and kind of stare at you a little bit. We'll go in the back. So we got Luke, Mackenzie, Gavin, Tony, Maggie, Brian, Nathan. Congratulations on your race, Nathan. Grace, Kayla, Joshua, Josh, Madison, Adam, Peyton. We got Peyton Rader and Peyton Burns. Okay, Peyton. Cole, Serenity, Auburn, Tyler, Aaron, Lane, Cole, Emily, Peyton, Mia, Cooper, Jacob. Also, I'm gonna pass around, this is the, I typed up the textbook form. I just need you to double check and make sure I have the right book number on for your name. So this will be official. So it's on there, just double check it. If as long as it's good, pass it on, okay? Each man.
Your attention, please. At this time, we need Mrs. Carpenter's class, Mrs. Cochran's class, Mrs. Lingo's class, Mrs. Martin's class, Mr. Spears, and Mr. Schlembeck's class. Please go to the performing arts hall for this. Thank you.
Did you guys get this yet? Yes? So, did you guys get it? So, right here. I know you get these two first. Good? All right. Yeah. Oh, yeah. Thanks, sir. All right, your answers are 3x over y squared and negative 8x to the 13th over 9 y to the 13th. Do they have to be written that way? Yes. Yes, they have to be like that. Now, with some minor exceptions, if somebody wrote a negative 8 and put the negative up beside the 8, that is perfectly acceptable. That's fine on that. But no negative exponents. Yeah, you gotta have it. Now, I'm going to teach this today. So, like, you're like, I forget. That's okay. That's what we're going to go over today. But I just want to give you a little bit of prodding to see what we're doing. Got it? So like I said, this will be on the quiz on Wednesday, but we'll go over it here today. I'm not even going to talk about it. I'm not even going to talk about these two problems. We'll hit it, and by the end of the day, you'll know exactly how to do them, or you should for that. All right, I'm going to go over 9 rules. Okay, there's 9 basic rules. You know, you've had them before. We're going to hit them and boom, move on. I'll give you a quick example of each. So here on the left-hand side, I'm going to give you the general rule, and over here on the right-hand side, I'm just going to give you like 1 and sometimes 2 like little quick examples to demonstrate it. After the first 3, I'm going to do like just a couple examples of just some things that kind of trip some people up as we go through there. But anything to the 0 power 1, this is things you've already had, things you know, you just need some reminding. I know that. And what that means though, couple cases here. So 4x to the 0, that actually equals 4 because the x is the only thing to the 0 power. That is 1. 4 times 1 is 4. If you have a quantity to the 0 power, that's going to be the whole thing is in 1. It doesn't matter how many things are in that parentheses. If it's all to the 0, it just becomes a 1. All right, so anything to 0 is 1. Now, I said you can't have negative exponents. Remember how we deal with negative exponents. A to the negative n. If you have anything to a negative power, then it becomes 1 over the positive power. Okay, for that. So x to the negative 3rd is just 1 over x cubed. For a constants, when we're dealing with constants, I do want you to simplify them with the exception of something like that's going to give you an outrageous number. So if you have 5 to the 15th power, you don't need to write down what that constant is. But if we're dealing with anything, you know, 3rd, 4th, 5th power, as long as it's nothing too crazy, I do want the constant. So 2 to the negative 4th, that becomes 1 over 2 to the 4th, that's 16 for that. Now, likewise, if it is in the denominator as a negative, to become a positive, you just kick it up to the numerator. So if it's a negative, we say move it over the fraction bar. So if it's in the top, go to the bottom, bottom, go to the top. Okay. So for an example of that one, okay. And now one thing you got to watch is once you talk about this rule, people want to move everything. It's only negative exponents. So this negative 2 here, this negative 2 doesn't move. It stays in the numerator. The y to the negative 3rd kicks up. Negative 2y to the 3rd. 1 over 3 to the negative 2nd is 3 squared. Make that a 9. Okay, make that a 9. All right, so those first 3. Now here's what I want you to do. Take these 4, and I want you to see what you think those answers are. Okay? Then we'll go back over them. Watch your positives versus negatives and make sure everything is simplified. If you need to use your calculator for the math, that's fine, but don't just type it in, the whole thing as it is, and hit enter in it, because that defeats the whole purpose. You're not going to figure out if you made a mistake or not.
Thanks.
Does everybody have a planner? Just want to make sure for the handbook. I got a couple extra. you get it? Did you guys get it? So everybody got it. All right. Everybody's good on their book. We're not worried about the condition. I just want to make sure those numbers are correct. So don't lose them. Make sure your name's inside of your book as well. All right, Jacob, what do you think for the first one?
I said 1/216.
Okay, so that's 1/6 to the third, and that will become 1/216. Good with that. Cooper, how about the B?
Can I ask a question about it first?
Why'd I put 1216? Hopefully that's not your question. Which question?
When there's an exponent in there and there's not on letter C, for example.
Yep.
And the negative is inside the parentheses.
Okay.
So if the negative's not inside the parentheses on letter B,
Right,
then you would leave that until the end, correct?
correct. They're two different, it does make a difference.
Yeah.
The
Okay.
way it's written. So what do you think the answer is?
1/-4.
All right, 1/-4. I would want you, and I'm gonna ask you, I'm gonna tell you to write that as -1/4.
Okay. Yeah.
Okay, don't write any answers like with a negative in the denominator like that. That's just like bad math. It's not incorrect, but make it, now, because technically here, this negative is not part of that 2. That negative should stay up there, and it should be 1/2 squared. Okay, which is going to be -1/4. Those are equivalent, but I want you to write it like that or put the negative out in front. Got it? No matter what, so kick that back up front. Mia, how about C?
I got 1/81.
1/81, yes, and it will be positive because that is 1/-3 to the 4th. Since that is in parentheses, now you treat it as -3 times -3 times -3 times -3, which gives us positive 81, okay, for that one. And Peyton Burns, how about D? Good, -1, because that negative is not to the power, so it is just 7 to the 0 power. You got to make sure it's -1. So double check your signs and make sure you simplify. All right, we're good on those? All right, so those are the first, and then these come up a lot. They can throw you off at times. All right, the fourth rule, and you'll recognize these as we continue. When you're multiplying variables, you add the exponent. So a to the m times a to the n, add them. So that's going to be, x to the 5th times x squared equals x to the 7th. The one thing about exponents, which is good and bad, is that you can do these in multiple ways and still get the same answer. Sometimes it's hard to explain because one person's thinking one way and one person's thinking another. But you also have to be able to throw negatives in there. So like if I have x to the -4th times x to the 8th, okay, I don't need to worry about the -4. I can just add these and do my work here. -4 plus 8 is just x to the 4th. I can just do that like normal. Now if I got -5 times x to the 12. Nope, let me make it -12 and +5. That's x to the -7. Then I gotta write my final answer as x to the 7th. So you still gotta go through your rules there. No negative exponents. Power to a power. A to the m to the n power is a to the m times n. Y cubed to the 4th power is now y to the 12th power. Okay, y cubed to the 4th power. If you have y to the 6th to the -3rd power, multiply those together. Y to the -18th, got to make it 1/y to the 18th. Or that's a negative power, you can make it 1/y to the 6th to the 3rd power. Then it becomes 1/y to the 18th. So that really doesn't matter which order you get there. You got to get there, get to the same answer. If you have more than one variable or coefficient to the power, you have to take everything to that power. Okay. So 3x to the 3rd is 27x cubed. All right, so just do that real quick. Amuse me. 2x squared to the 4th power. Emily Cosine, right? All right, let me know what you got. What do you get?
Is it 16x to the 8th power?
Good, 16x to the 8th. Good. Make sure you take 2 to the 4th and you take 2 times 4. You don't, I mean, there's still the tendency to want to multiply 2 times 4. Remember, you're taking it to the power. The coefficient 2. So 16x to the 8th. All right, good there. All right, now in the division. If you are dividing, then you subtract. Okay. X to the 8th over x cubed. X to the 5th. All right, what if I flip it around? X to the 5th over x to the 8th. Okay, you still got to follow your rules. And then that's going to be x to the, now some people ask, well, I don't know, where does it go in the top or the bottom? Whatever order you subtract, that's where that answer goes. If I'm doing 5 minus 8, it has to go in the numerator. Okay. So which is going to be x to the negative 3rd, and you make 1 over x cubed. A lot of you are just going to say, I already know the answer is 1 over x cubed, and go that route. That's fine. I mean, if you just do this mentally, 8 minus 5 is 3. If they're both positive, the answer has to be wherever the higher exponent is. I don't really care. If you have, but you've got to watch x to the negative 6 over x to the negative 10th. You can either flip those right away, or you can use the rule, negative 6 minus negative 10, which is really negative 6 plus 10. So the final answer is going to be x to the 4th. Some of you might say, well, I'm going to move that up and make it x to the 10th. I'm going to move that down and make it x to the 6th. It doesn't matter, okay? And you're going to, sometimes it will be easier one way. Sometimes it doesn't matter. If I have a quantity to a power, then that power goes to the numerator and denominator, okay? So 2 over y to the 3rd is 2 cubed, make that 8. Don't give me 2 to the 3rd power, make it 8. And then y to the 3rd power, okay, for that. And the last one here, this is kind of it's a nice one to know if you remember how to use it. It makes life a little bit easier. If you got a over b to the negative n, the kind of the quick route is just flip the inside. You just flip the inside, and then you make whatever's negative on the outside positive. Okay. So x over 4 to the negative 3rd flips, and it becomes 4 cubed, which is 64 over x cubed for that. Now, like, you can go through all the steps. I mean, theoretically, you could, because I can make this a to the negative n over b to the negative n, and then I could make this a positive power, and then I could pull out that n, and I could eventually get there, but you just need to know that you flip that. Do not change any of your exponents if there is anything on the inside. Those will stay the same. All right, that's all our rules. Now I want to go over some more not so basic examples, just to kind of hopefully help it sink in. First two really aren't they're pretty straightforward. All right, on number 1, all right, as you copy that down, let's use our exponent rules. Don't figure out what 2 to the 5th is at this point, like multiply everything again. Let's get it into its simplest form before we do anything. If I use my rules, 2 to the 5th over 2 cubed is going to be 2, what, squared? 5 minus 3. All right, negative 2 minus negative 3 is what? Positive 1. So it's times 3 to the 1st. All right, now you can just finish this from here. 2 squared is 4. And if I'm going to get a not too nasty number, I want to multiply it out. So make sure that's 12. All right, number 2, there's really no work to do. You just have to write it in the proper form. This would not be an okay answer. You cannot have a negative exponent. So what's that gonna look like when we're done? Make sure you don't move that 5. Make it negative 5x squared over y cubed. All right, copy down that third one. Okay. The 4x is not involved with the parentheses, so don't take it to the power. Make sure you don't do that. The 3 gets squared, make sure it's a 9. Don't do 3 times 2, do 3 squared. And negative 2 times 2 is negative 4. Okay. 4 times 9, now you gotta multiply everything together and simplify, is x is 36. And now you got x times x to the negative 4. Then your rules state you add the exponents. For me, that's probably the quickest way, and I'm gonna get x to the negative 3rd, and then in the end, I get 36 over x cubed for that. Done. Okay, nothing else to do. All right, for that fourth one, you have to simplify the denominator first. Order of operations still holds, which means I cannot take 15 divided by 5, or I cannot take x cubed over x squared and simplify those. Got to take care of the denominator first. So the 15x cubed over or times y to the 4th gives me over 25 x to the 4th y squared. All right, what happens to the 15 and 25? They are not exponents. Do not try to subtract those. It is a fraction. 15 over 25 reduces to 3/5. You're basically going to reduce it. On my exponents or on my variables, x to the 3rd over x to the 4th will leave me an x in denominator, and I should have a y squared in the numerator. Okay, for that. All right. Any questions to this point? All right. All right, now this is similar to the one we did in the beginning of class, and write it down, but then I wouldn't get ahead of me. Again, multiple ways to do a problem, but here's what I would do for this one. With this negative 3, I can move that to the denominator. I would do that right now. Okay. Keep this first part in the numerator, 3x y to the negative 2nd to the 2nd power over, and that'll become 4xy cubed to the 3rd. It's just more difficult when you have a constant to that negative power. If you move it down below, make it a positive, it just makes, there's fewer mistakes. Now, 3 squared is 9. Go ahead and finish it. Go ahead and finish it, see what you get. If you're not quite sure, then just hold on, I will do it. Okay. So I got, let's see, 3 squared is 9. Now we got x squared, y to the negative 4, over 4 cubed is 64, x cubed, y to the 9th. 9 over 64 doesn't reduce. X squared over x cubed gives me an x in the denominator. And then -4 minus 9 is -13, but that's got to be moved down below. So in the end, you have 9 over 64x y to 13. For that. Not the only way you can get there, but I just suggest when you got a quantity to negative third, I would move the whole thing down just right away. Now I want to do one where we have, you got a fraction, we got a negative power. Okay, 3x squared y to the negative third over x to the negative first, y to the fourth, z to the negative second. All right, all to the negative third. If you have a fraction of the negative third, you can flip everything and make it positive 3. But when you flip, do not alter any of those inside exponents. So this becomes 3x squared y to the negative third in the denominator, x to the negative 1, y to the fourth, z to the negative second in the numerator. And now you can apply everything to the third power. And then I get x to the negative third, y to the 12, z to the negative 6, over 27, 3 cubed is 27, x to the 6, y to the, what is that, negative 9? All right, finish that up. Cole, let me know what you get when you're done.
Okay, I got y cubed over 27 x to the 9 times z to the 6.
Double check that y. Okay, because you gotta take 12 minus negative 9. So that should become 12 plus 9.
Okay.
Looks like that's gonna be what, 21?
Attention, please. The photographers are now ready for Mrs. Havinger's class, Mr. Kell's class, Ms. Bosworth's class, Ms. Jones' class, and Mr. Webster's class.
Holy cow.
Please go to the performing arts room.
All right,
Now to have your picture taken.
let me just talk about this. This is something you've gone over and you should know, and then we just did it instinctively on all these problems, but how do you know when to stop or what are you heading to? You gotta know that each base, each variable, x or y, whereas it only appears once. You cannot have an x on the top or an x on the bottom. No negative or zero exponents, absolutely not. That's not simplified. You gotta just change everything to positive. No power is raised to a power. So, what are the 3 x squared to the third power? You can't leave that, okay? And then all fractions are reduced, okay, which you kind of do instinctively. So that's kind of the formal steps for simplifying, and I think you kind of already know them as you go through there. I want to give you a little bit of time here. Go ahead and get started. Now, page 27 and 28. Start this on a separate page. As soon as you get done, you can, upload it. I don't know if you'll get done in class. You might. Here's what I am going to ask you to do. I want you to check all your odd answers in the back of the book from till today to the end of the year. That doesn't mean copy them from the back of the book. You are checking to see if you're doing these right. I suggest you do like 2 or 3 problems, check them. If you really think you're unsure about one, go ahead and check right in. Don't wait till the very end, because a lot of times if you did them incorrectly or you have the wrong form of the answer, you can figure that out ahead of time. There is a rare case where there might be an answer in the back of the book that is incorrect. There's like 2 or 3 of them. And I forget which ones, like all year. So like if you just come across one where you absolutely are positive you're right and the book's wrong, well, that might be a case. Okay. We will have a quiz Wednesday. It'll be 40 summative points over factoring and exponents, which is actually section P2 and P4.